Hello everyone. In last class we were discussing about coordination polyhedron. The coordination polyhedron is nothing but the spatial arrangement of ligand which are directly attached to the central metal atom in space, right? That is spatial arrangement of ligands which are directly attached to the central atom is explained by coordination polyhedron, and you can observe tetrahedral, square planar and octahedral spatial arrangement commonly, right? Let us discuss the structure of these coordination polyhedrons. First one is octahedral. Central metal atom and is directly connected with the ligands. Ligand so towards the observer, right? Solid line, solid wedge, and that is broken away, and it is two more ligand. It is a octahedral polyhedron. Next one is a tetrahedral. Central atom, that is metal atom, and is directly attached with the four ligands. Okay, four ligands. So away from the observer. Tetrahedral polyhedrons. These are four ligands. And next is square planar. Metal and four ligands. Right? Metal and four ligands. This is a square planar. Square planar. All four ligands are in the same plane. Next is trigonal bipyramidal. Here it is metal atom. These three ligands are in a single plane, and here two more ligands. This is a trigonal bipyramidal. Trigonal bipyramidal. And next one is a square pyramidal. Metal and here it is a here it is solid wedge, like this solid wedge, and here it is broken lines. This is square pyramidal. pyramidal, square pyramidal structure. These are different coordination polyhedrons. Hope it is clear for you. Most common polyhedrons are octahedral, tetrahedral and one more square pyramidal. So here it is solid wedge. Fill this, okay? Okay, that's all. Now let us move to the next topic, important one, that is homoleptic and heteroleptic compounds. Let us discuss what are homoleptic compounds. If central metal atom is directly attached to same type of ligand or same kind of ligands, then are called homoleptic. Homo means same, right? If the central atom directly bonded to same kind of ligands. If it is bonded to different kind of ligands, then are called heteroleptic compounds. That's all. They'll ask for 2 marks with the example. Homoleptic compounds or homoleptic coordination compounds. Homoleptic compounds. The central metal atom or ion, the central metal atom or ion, bonded to only one type or only one kind of ligand. Clear? If the central metal atom or ion bonded to only one kind of ligand, then are called one type of ligand or donor group. It is one and the same. Donor, one kind of donor group or donor groups, then are called homoleptic. Example, cobalt and H3 ammonia 6. See, this central atom is cobalt, is bonded to ammonia, that is 6 ammonia molecule 3 plus. It's a cationic part, okay, complex ion. Or PtCl4 2 minus. Here also central platinum ion directly coordinated to 4 chloride ions, right? There will be one more counter ion, but here central atom is directly attached to what kind of ligands, whether different kinds or of a same kind. Then we decide whether the coordination compound is a homoleptic or a heteroleptic. Next one is heteroleptic complexes. Heteroleptic complexes or homoleptic complexes, compound or complexes. What are heteroleptic complexes? Complex is coordinated complex or coordination compound, one and the same. So it forms complex ion, hence we call it as a coordination compound or coordination heteroleptic complex. Yeah, the central metal atom or ion is bonded to different different kind of donor groups. Donor groups or different kind of ligands, right? Different kinds of ligands or donor groups then are called heteroleptic compounds. Example, cobalt NH3 4 times and Cl2 plus. And one more example, cobalt SO4 and NH3 5 times. Just go through only any one type of any one example, okay, which is find easy. Just remember that. Okay, these two are easy examples. First their second and first one. It's your wish. Yeah, this is about homoleptic and heteroleptic complexes. Next, we'll move to the next topic, that is ligands. No need of giving these examples only, you can give any of the examples, okay? But central atom must be attached to same or different kind of ligand or donor groups. Now what are ligands? Yeah, ligands are nothing but these are donor groups which are directly attached to the central metal atom which donates one or more pair of electrons to the central atom. Clear? Ligands are directly attached to the central atom which donates the pair of electrons to the electron deficient central atom, and these ligands are electron rich. It may be small ions like chloride, sulfate, etc., or neutral molecules like water or ammonia, right? Those ammonia those two molecules can donate electrons. In ammonia, NH3, nitrogen containing lone pair of electron, it can donate a pair of electron, a single pair of electron. And this again, water, H2O, oxygen can donate a pair of electron, or EDTA, ethylene diamine tetraacetate or tetraacetic acid. It can donate 6 pair of electrons. The density is 6, like that. Okay, it has 6 coordination centers. It can form 6 coordinate bond, like that. It's a polydentate. So these ligands are directly attached to the central metal atom. Ligands are the ions or molecules. Ligands are ions or molecules directly attached to the central atom and having one or more donor atoms. Just to give definition, the ions or molecules having one or more donor atoms and each donate a pair of electrons, and each donates a pair of electrons to the central metal atom or ions, to the central metal atom or ion to form coordinate bond or coordinate bond to form coordinate bond. Okay, just you must know the you should know what is ligand, that's all. No need of biting definition and all. That there will be a central metal directly attached to the some donor group, some groups which can donate electrons. Those groups are called ligands, which are able to donate at least one pair of electron. Okay, that's all. And as I said, ligands may be simple ion or small molecule or a larger molecule. Okay, simple ion example, it may be ligand may be simple ion like Cl minus, or small molecule like NH3 ammonia, right? It can donate electron. Or water, through oxygen it can donate a electron. Cl minus, excess of electron is there in chloride ion. Or larger molecule like EDTA, ethylene diamine tetraacetate. And in rare cases, in some proteins, NO plus, that is cation, can act as a ligand. It is in a very rare case. In case of sometimes in proteins, NO plus can also act as a ligand. Now let us move to the next topic, that is types of ligand. Based on number of donating groups present or number of point of attachment a ligand can form. Based on that, ligands are classified as monodentate ligand, bidentate ligand and a polydentate ligand. If a ligand can donate a pair of electron, that is single pair of electron, that is 2 electrons, one pair, single pair of electron, then are called a monodentate ligand. It can form one point of attachment, right? There will be a central metal atom and there will be a ligand. If this ligand can able to donate a pair of electron, one pair of electron, it can form single point of attachment, right, between metal and ligand. This type of ligands are called monodentate ligand. If metal and ligand can form, if there is like this one, it's a ligand, if it forms 2 points of attachment, right, or a ligand, a single ligand or donor group can donate 2 pairs of electron, then are called bidentate ligand, right? I have given example already. If there is NH3, then this nitrogen can donate a pair of electron, right? Hence ammonia is example for a monodentate ligand. Next, ene group, right? What are ene groups? Ethylene diamine. So now this ethylene diamine can donate 2 pairs of electron, right? It can coordinate like this, right? There will be 2 coordination sites. Then are called bidentate ligand. And one more, polydentate ligand. It may be tri, tetra, penta, etc. We'll discuss later. We can take EDTA as an example, ethylene triamine as an example. Okay. Hope it is clear for you. Monodentate ligand. A ligand donates a pair of electrons. A ligand donating a pair of electrons and coordinate or bound to a central metal atom, to a central metal atom or ion by a coordinate or coordinate bond, by a coordinate bond, by a single coordinate bond. Or these monodentate ligands form one point of attachment. Central metal atom. One point of attachment we can observe. Example: Cl minus, water, ammonia, etc. This is about monodentate ligands. Next is bidentate ligand. A ligand donating two pairs of electron. I'll change here itself. Monodentate is over. Bidentate ligand. What are bidentate ligand? A ligand donate not to a single pair of electron. It can donate two pair of electron and bond to a central metal atom by two coordinate bond. Right, there will be two coordinate bond and here two pair of electron form 2 point of attachment. 2 point of attachment to the central metal atom are called bidentate ligands. Next is polydentate ligand. What are polydentate? Example for bidentate ligand is simple example: ethylene diamine or oxalate ion. This is to our example for bidentate ligand. What are polydentate ligand? Hope it is clear for you. If I change, I think you can make out, right? What are polydentate ligand? A compounds in which metal atom is bonded to more than two pairs of electrons. A ligand donating more than two pairs of electron and bond to central metal atom or ion by again more than two coordinate bond. More than two, then are called poly. More than two coordinate bond, and here also more than two pairs of electron can attach to the central metal atom. This polydentate ligand may be tridentate. Tridentate. What are tridentate ligands? There will be 3 donor atoms and 3 coordination bond. 3 donor atoms or donor groups and 3 coordination bond. Right? If there is 2, then are called bidentate. 3 tridentate. Again tetradentate. Right? 4. Next pentadentate, etc. Right? Pentadentate. 5 coordination bond and 5 donor atoms. Or hexadentate. Hexa means 6. 6 coordination bond and 6 donor atoms will be there. Let us discuss example for bidentate and polydentate ligands.